Let's first understand AC generator in principle. Then we will see the mathematical model of it. Then we will see how to get the equation of, uh, uh, the EMF, AC EMF that you get. So drawing wise is very simple. Okay, I'll give you time to draw. Let's just first understand. AC generator is a device where you use mechanical energy. Generator means you have to rotate something. Mechanical energy will be converted into electrical energy. The whole idea is you get electricity or you get electric current only when the flux linked with a coil changes. And now the story is almost rotten for you, how to change the flux, move the magnet, increase the magnetization, vary the magnetization, or move the coil. So here we have fixed magnets and we rotate the coil to an axis. Okay, there will be an axle which will be rotating this coil, and if the coil rotates, then you have understood that there will be magnetic flux linked with it will change. Now what is the idea? Brief. What is magnetic flux? dA cos theta. So every time you rotate, the theta is going to change, right? So let's just have one broad level of understanding, though this was earlier in grade 10. So let's see what is the difference between this one and a DC generator. Okay, only difference you will get, these are two magnets, this is the coil, and this is the most important part. This is called slip rings, SLIP. They slip over these carbon brushes B1 and B2, right? Now what is the job of this carbon brush? Just try to understand. Ultimately I will be getting current from here. So in order to use this current, I must connect some wires with it. If I connect the wire directly with the coil, won't your wires get entangled as it rotates? Yes. So what sort of arrangement we did? Wires come and connect with fixed carbon brushes, the brush, and the ring keeps on rotating and keeps on sliding on the brush. So if there is a current in the ring is passed on to the carbon brush. Have you understood? That's why when you go for your mixer grinder repairs and all, the common problem that comes up in your mixer grinders, though that is a motor, they'll say brush gis gaya. The brushes have worn off and they are a replaceable part. Even in drill machines, the brushes will go, they will get worn out. Have you understood? Brushes are fixed, and on this is a fixed brush on which a particular ring is constantly rotating and abrasing it. Is this concept understood? This ring is a solid ring, which means if you look at this arm CD as an arm is always in contact with R2 ring, always in contact with R2 ring. Rather, R2 ring is a joint part, is a part which is joint with CD. So if CD rotates, R2 also rotates. Have you understood? And R2 while rotating will always make physical contact with B1. Clear? Similarly, whenever BA is rotating, how is BA rotating? Children, this coil is in this manner. It will keep on rotating in this manner. So when BA is rotating, then R1 is an integral part of BA. So if BA rotates, R1 also keeps rotating. Have you understood? And this R1 slip ring is always in contact with B2. It brushes B2. Is this understood? Let's apply some common sense out here before going further, and then we'll give you some time to draw, and then we'll see the mathematical model. Okay, so let me see. Now let's look at this arm CD. Let's look at this arm CD. The magnetic field is on this direction. Do you agree? And if you see C is going inwards. So let's say C is going inwards out here, right? So this is the magnetic field B, and this is my motion or the force that we have given, right? Now this is electromagnetic induction. You can use this type of rule that I told you, or if you're fine with Fleming's right hand rule, absolutely fine. Left hand rule is always used for force on a conductor. Right hand rule is always used to find the direction of current, right? So let's see the direction of current. Same, F, B, I. So B is going in which direction? This direction. F is going in which direction, beta? F is going inside now, right? This is going inside. So my current is downward. Have you understood? The current is downward. So let's say downward current means, and I have to give some sort of a sign to it. Let's say the downward current is positive current. Let's imagine. So right now, if you see, B1 will be having positive conductivity with it. Is this much understood? Right? At the same time, let us see what is happening in AB also. AB has got magnetic field on this side, and when this goes in, AB will be coming out. Oh, AB will be coming out. Right. So if this is B, then this is F. Is this understood? This one goes inside means this one comes outside. Clear? So let's have a look at with right hand theory once again. My FBI, my B is in this direction, F is coming outwards. So the current is now pointing in the upward direction. Have you understood? FB, F current is in upward direction. So what I do, I put the current in upward direction. This current is in upward direction. And let's say upward direction is negative. That means this part is negative right now. Mechanically, let us first understand. Have you got it? As soon as it rotates, then this C will come in this side. CD will come this side. See, right now the coil is like this. After it makes half a circle, this is what? This is CD. CD goes and comes in contact this side, and AB comes this side. These don't change. These don't change because they are always in contact, right? But what has happened now? My CD in the next half cycle will be trying to come out. So CD in the next half cycle will take a negative current. And similarly, in this one, I will get positive current at that time. So when this is positive, this is negative. When this is negative, this is. So in every one cycle, twice this will happen. Once during the start, half cycle, change over 1, change over 2. Twice it is turning. Have you understood? This is the very vague idea. But if you think, sir, what happens in a DC generator? In a DC generator, we have got a very simple funda. Instead of creating slip rings, we have split rings. Split. The DC generator is very stylish. The DC generator will be just like this. There will be a split ring here and a split ring here, like this. So when you are trying to rotate it, let's say this is S1. S1 is in contact with B1. S2 is in contact with B2. When it rotates, S2 comes with B1 and S1 goes with B2. Therefore, one side will always have the same polarity of the current. Are we able to picturize, or shall I draw and show you? Yeah, I'll draw and show you. Don't worry. Okay. So it's like this. See. Let's see the DC generator here. Same, no difference. The difference comes here now. Half ring, and then you have your brushes. All right, let's put our brushes here. So let's say, let's put again the same names: A, B, C, D. This is slip ring S1, this is S2, this is B2, this is B1. Have you understood? They are in contact. Clear? Now this is a DC generator. DC generator means what, beta? Whatever will be the polarity on B1, it should always be the same polarity. So you're taking wires out from here and wires out from here, and you put a galvanometer. Right? Let's see. Let's have a look at our magnetic field. Okay, let's have a look at our magnetic field. So let's say the magnetic field runs on this side, and which side are you giving your what you call force? This is going inwards. Force is going inwards. Correct? So what should be the direction of the current? The direction of the current should be downwards, exactly like this. And I'm taking downward current as positive. That means my B2 terminal, B2 is the brush. B2 is sensing positive because S2 is sensing positive. Understood? At the same time, if I draw my diagram on this side, this is the direction of B. right? And then this is the direction of F. So what is the direction of current? The current is going in this direction. This is the current of direction, let's say negative. So this is negative. Till here, no issues. Why did I cut it? And here it was a whole solid block. Here we have cut it. This is not, we don't study this because you don't study direct current out here. Now say, now how is the rotation's direction? The rotation direction is, say this side you are rotating. This has gone inside, or rather to make it more interesting, let's write it this way. Say it's going this side. So this has gone in. Now imagine the next half cycle. Okay, now I'm doing everything with my white pen. When this is the next half cycle, this becomes C and this becomes D. Do you agree or not? Right? What is attached with them? If this becomes C, this becomes D, then this fellow becomes S2. S2 is attached with them. But B1 is fixed. Are you understanding? B1 is fixed. Okay, B1 is fixed. So let's see what is happening. When in the half cycle, when it comes this side, then what is the direction of current? Direction of current is still up. So my S2 comes here and the direction of current becomes, this will come and rotate on this side. At that time, the direction of current on this particular S2 will be what? Negative. Do you agree? So B1 was earlier sensing negative. Due to the rotation also it is sensing negative. Did you understand this thing or not? Or should I repeat it once again? Once again? Yeah, they're touching B1 and B2. So once again, okay? Let's start the discussion once again. Don't worry. Okay. B1 is sensing, till here is it okay? B1 was sensing negative. It's in this manner, like this. Now, this is CD. CD carries the S2 along with it and comes in contact with B1. Both rings touch both. Yeah, both the rings are touching both the brushes right now, Zoe. Both the rings are touching both the brushes. Split means what should I say? A broken bangle. One arc S2 will touch B2, the other arc S1 is touching B1. Fine. Yeah, halfway rotate. So brushes are here. See, you should have asked a different question. Brushes are here. I'm in contact with both the brushes. Now you make me rotate. Half cycle. Again, I should come in contact, right? Both the ends? How can both the ends touch? It's like this is a brush. A brush is just like a toothbrush, and the arc is a semi-arc which is like this. It's touching here, and it rotates. So the semi-arc from here becomes here. It comes in contact with this. At that time, that one is come in contact with this one, right? Achha. Have you gone to IKEA? Through the entrance door, have you seen the IKEA's entrance door, which is a circular entrance door? Let us position me and Arjun, we stand diametrically on either sides, right? Where we are the carbon brushes. You and Neha are on both sides. You all will just put your hands out. You are shaking hand with me. She is shaking hand with Arjun. Arjun will not move. I will not move. Now you two girls move along with the door. Next time you will be shaking hands with me and she will be shaking hands with him. Do you agree or not? No. It's not like that. They will always be in touch with one at a time. Rather, what you should ask, sir, won't there be a time when me and Neha will be such that none of us will be shaking hands with either of you? That is also possible, right? The brushes are here. There is a chance you'll be like this also. What happens at that time? That question also we will answer. Which one? No. It's not like that. It's split. It's split. There will be a moment when you will be out of the contact of two brushes. That's why I gave the IKEA door example. We are standing here, you guys are here. The door rotates with you two. Now you two are at Kashmir and Tamil Nadu. We are at Assam and Gujarat. Do you touch us? No. Have you got it? So we'll see that scenario. Now just understand this. CD has come on this side. Is this agreed with you? If CD has come on this side, then S2 has also come on this side. Right? Now the contact is S2 is in contact with B1. Agreed? Before S2 came this side, B1 was sensing negative. Once CD comes this side, the current on CD will be now on the negative side, upward. So even after this orientation, B1 senses negative itself. Did you get the idea or not? Whereas by this time, B will come here, A will come here, this one will go here, right? And whoever comes here, the current is always downwards. That means we will have S1 come here in contact with B1, and S1 after this orientation change still senses positive. That means B1 also senses positive. So B2 will always carry positive direction, B1 will always carry negative. This is a DC generator, and this arrangement is actually known as a commutator. A commutator is the arrangement, this is not in your syllabus, it is with the ring as well as the brush. The job is to commute the current outside. You can't connect something with the coil. Did you understand? Question is, when it comes into that Kashmir and Tamil Nadu position, what current am I getting? There is not one coil. There are thousands of coils. Somebody is in touch. When you are moving your touch, somebody else coil. There are many coils like this, coils, coaxial coils, just like the IKEA door. You two guys went on here. There can be two more children on the other side. The IKEA door is like this, right? You two were here and here. Now you two went there. There will be somebody here who will be in touch with us. So we will always shake hands with someone, not necessarily you two always. Got it? If you do the same thing with, now just apply the same thing, the DC generator, you apply force on it, then it becomes a, what you call the DC generator, which you were applying force and you were getting current. If you apply current to it, it becomes a motor. Obviously. And that's what that day to grade 10 children I had brought this. I had showed this to you all also, if you remember. This is a DC motor. This is a motor, right? If I turn this switch on, the motor is rotating in this direction, right? This DC motor, let's make it a generator. If I turn this side also, current is getting generated, but this is LED. LED is polarity sensitive. It will not glow. If I put a torch bulb, the torch bulb will glow. More faster flux linkage, more EMF produced, more current produced. And if I, this is motor, and then this is generator. This thing was there in our bicycles. We used to have this connected with our tires, and when we pedal our cycle, the generator used to rotate. Have you got this fair bit of idea now what happens, right? So if you, this diagram, have you understood, right? There's one more diagram also similar. This is how the magnetic flux changes as the coil. See, the coil will always rotate with this. Any doubt till here? The only difference between a DC generator and an AC generator is that since here it is a constant ring, the ring will sense positive, negative, positive, negative, positive, negative. But in this case, when it comes on this side, it senses negative. When this one comes on this side, senses negative. So B1 is always negative. B1 is always negative. Whereas if you look at B1 and B2 out here, since the ring changes this polarity, B1 and B2 are also changing their polarity, and it's constantly touch. This one never comes in touch with this. Whereas here, there is an alternation. S1 comes with B1, S2 comes with B1. S1 B1, S2 B1, S2 B2, S1 B2. Here, always the relation with B, R2, this is R1, R1 B2, R2 B1. This will be the pairing. Are we fine? At the halfway mark, it will change sign. That we will see mathematically, because when you come this side, then only the current will change its direction. See, in order for the current to change direction, imagine, go very basic. What are the inputs? The inputs are magnetic field and motion. Magnetic field on this position and this position are always same. So magnetic field is not the guy who is causing the disturbance. Motion. Here you are pushing inside, say you get a positive current. Here you are pushing outside, so you will get a negative current. Again, you had a negative current and you went this side. You're going in. Now you become positive again. So the current fluctuates. Okay? So you will be, so our idea will be that every time what is going to happen, can I change this? You want to draw, you can draw. You will always have slip rings, and slip rings are responsible for the carrying the alternate current out. Did you understand the funda or not? Or you want me to explain again? I can explain you. See, in an AC generator, one side is always going to have a different polarity when it goes to the other side. And since it is continuously with a particular slip ring, so the slip ring, if your polarity changes, slip ring's polarity also changes. Right?
AB is not
AB is not in contact. The drawing is such, AB is in contact with R1. AB is for R1. Right? That's why you can see this diagram. This is better. The red one is in contact with the inner one. The indigo one is in contact with the outer one. This contact will never break. And this yellow will always be with this. This one will always be with it. But if you see DC generator, this elongation is not there. They are at the same level. And the rings are cut. So which one? For that wave we will see now. End of the day, we have to get a wave. We have to get the equation of the EMF, which will be your raw material for the next chapter. Okay? Let me know when you want me to start, so you can. Simple drawing, you just make one magnet like this. Make one magnet like this. That's it. This is not required. That is important. This is only for your interest purpose. The very funda you have understood. You rotate a coil within a magnetic field. So the flux linked with this coil will change. As a result, an EMF will be generated in the coil. If the coil is connected to an external circuit, which is a galvanometer as a load out here, then a current will flow through the coil. And I explained you based on grade 10 knowledge why the current direction will be changing, and you understood one thing very nicely, that the current direction changes every half cycle. What is a full cycle? Let's consider, is it a what you call periodic motion? Yes. A periodic motion is a motion which repeats. Rotational motion is also periodic motion. When will you call it one period? When this comes back here. By the time it comes back here, how many times the current will flip? Twice. Twice. And that will actually be, twice means, what is the frequency of flipping? 2 times. That will be called the frequency of the signal. So in India, the frequency of the signal is 50 hertz. Right? So it's per second, it is changing 50 times. So in one cycle, it will change 100 times. When CD comes back here, it will be considered as one cycle. Zoe was asking, right? Why did they show this? Half, half. Once you will get a positive, once you will get a negative wave. Okay, chalo. Shall we start? Right. So, okay, this one, don't worry, this is easy diagram. So, you understood now, there is a coil which is rotated, and at the end of the day, we need to understand that Faraday said the EMF generated is negative d phi b by dt. the negative derivative of the change in flux. Clear? So let's look at the flux now. What is the flux? The flux is given by BA cos theta. BA cos theta. All right. Let us say that this coil is rotating with an angular velocity. Angular velocity, and this angular velocity is omega. What is linear velocity? Displacement upon time. So what is angular velocity? Angular displacement upon time. Angular displacement is known as theta, right? If you have, see, if you have something out here and this thing has moved through a distance of theta in a time t, then this body will be said to possess an angular velocity omega is equal to theta upon t. Radians per second, rad per second. Clear? This much you have understood, right? So we now say, we have to have some assumption now here. At say t equal to 0, when the time was 0, we say, let us assume theta was equal to 0 degree. It's actually 0 rads. Okay, angular velocity you don't write in degree, you write in radians. When t was 0, that means theta. Now what is theta? Theta is the angle between what? The b vector and a vector. So a vector we should know a little bit more nicely. A vector is the vector. A vector is such that a vector is always perpendicular to plane of coil. Plane of coil. That means if you look at this figure, a vector will be perpendicularly outside. Have you understood? So when we are saying that at t equal to 0, theta equal to 0, look here children, theta equal to 0, theta, what is the magnetic field? The magnetic field is going in this direction, right? Magnetic field is going in this direction. So no issues. This is my a vector. My a vector should also be in this direction. So what can be the position of the coil? The coil is now just vertical. Then only this is the a vector. A is perpendicular to the coil. Have you understood this? So the coil is right now in this vertical position, right? So at theta equal to 0, we say how much? We say that at theta equal to 0, t equal to 0, theta is equal to 0. Is this much understood by you? Very good. So now come. I'm just, for your interest, writing it once again. EMF is equal to negative d phi by dt. Remember this. And theta is equal to 0 when t is equal to 0. When t is equal to 0. Right? Now, at time t, some time t elapsed. Look, for this to go from here to here, to here, t time elapsed. In t time, how much angle did you sweep? Theta, right? So we will say at time t, I will say omega is equal to theta by t, or I can say theta is equal to omega t. Any confusion here? Have you understood? It took you t time to sweep an angle theta. Who did sweep an angle? Area vector, because b vector is always constant. Who is changing the direction? A vector is changing the a vector was like this. The a vector was like this, and yeah, this is my, come on, this is my a vector and this is my b vector. My b vector is continuous. In time t, a vector swept an angle. How much is the angle? Theta now. Have you understood? Right, fine. So can I now write that my flux at a time t, has now become what? Equal to b a cos omega t. This is called instantaneous flux. Now the flux is a function of time. See how nicely earlier the flux was a function of theta. We now made it as a function of time. At time t, the flux is given by cos omega t. Agreed? Now, I have got how many coils? I have got n number of coils. So my total flux linkage will be how much? N phi b at a time t is given by NBA cos omega t. Do you agree or not? Right. What is EMF as per Faraday? Faraday says this is negative derivative of d by dt of phi b. Phi b means instead of writing phi b, I will write here as, I will write this as n phi b, where phi b is a function of t. If you don't write function of t also, it's fine. Okay? So let's make its derivation. Come on. N is constant, b is constant, area vector is constant. So all these constants come out. NBA. Look here, children. This negative, I have put this negative. Cos omega t's derivation. Cos omega t's derivation is minus sine omega t into omega. This is dog. dd dog of cos dog is minus sine dog. Then d dog of dt. Arjun, have you understood this part? It's like this, see. Cos t. If you try to do a derivative with respect to, then you get minus sine t. But this time you have cos omega t. So we apply chain rule, d omega t into again d omega t by dt. So basically this one and this one cancels each other. So what is cos? If ddx of cos x is minus sine x, dd dog of cos dog is minus sine dog. This. And what is the omega is a constant here, so you get 1 omega. Right. So our derivative will be what? Omega, then negative sine omega t. Have you understood? Negatives and negatives will cancel each other, so I can write that the EMF at any instant of time t. Now the EMF is also a time varying function. Yes or no? The EMF at any time t is given by NBA omega sine omega t. Yes or no? Children, is n constant? Yes. Is b constant? Yes. Is a constant? Yes. Is omega constant? Yes. It is rotating with a constant omega. 2000 RPM. Boom. It's rotating. All these are constant. So we replace this with a quantity called E naught sine omega t. Not epsilon b2. This is E naught. E naught. I know you did not have it so nicely in grade 11. But if you remember periodic function, y equal to y naught sine omega t, vibrations when you studied in springs. This is actually considered as the maximum value. We'll come to this. Is this much understood? E equal to E naught sine omega t. Right? So this is the equation of the alternating EMF at any instance of time t. Okay, bacha? So let's see some scenarios. Let's see some scenarios. So let me make some drawings, then it will become easy for you to understand. Okay. Okay. Now see. Right? Let's try and understand this. North pole, south pole. Magnetic field is always from north pole to south pole. Have you understood? In this orientation, I'll just draw one diagram, because the more diagrams I draw, the more it will get, what do you call, here my coil is in this direction. This is the coil. Have you understood? So how is the area vector of the coil, bacha? The area vector of the coil is in this direction, right? And I am doing some magnetic fields. Magnetic fields are always in this direction. Here also magnetic field will be like this, magnetic field will be like this, magnetic field will be like this. Have you understood? Henceforth, I will only draw the green one. Okay. What is the value of theta now? 0. Agreed? E is equal to E at a time t is given by E naught sine omega into 0. Sine 0 is 0. So sine 0, 0 means at this moment the EMF generated will be 0. Minimum EMF. Have you understood? The sine value is 0 out here. This rather than writing it as 0 out here, I'm deliberately putting the 0 here to understand that the sine value is 0. What about the flux out here, children? If you see the flux at this moment, then the flux is BA cos 0, which means the flux is maximum. So you can ask a question, flux was maximum, still voltage is 0. Why? Voltage has nothing to do with flux. Voltage has to do with change in flux. This chapter is all about that. Change in flux. Is this clear? Okay. In our next orientation, children, my coil is now in this orientation. Coil is in this orientation. Do you agree? Okay. Coil has rotated halfway. And how do you think the area vector should be? The area vector should be now coming out of the coil perpendicular, 90 degree. Yes or no? Push this vector here. Look, push the B vector here. These are all my B vectors. B. This is my A. This is B vector. This is B vector. This is B vector. And this is my A vector. How much is the angle? Now I will say E at this time is equal to E naught sine 90. Yes or no? Sine 90. Omega t. So instead of writing omega into 0, we will write theta. This is sine theta. So sine 0. Sine 90. And sine 90's value is 1, which is equal to E naught. You get maximum EMF out here. Max EMF you are getting. But if you look at the flux at this position, the flux has become BA cos how much? 90, which is equal to 0. Flux has become 0, EMF has increased. Because it is, see, look here. Faraday's law says very nicely, Faraday's law says EMF is always equal to negative derivative of dt, means reduction. What is this negative rate? Negative rate of population means every year births will be less. So if the flux is coming down, look here, if the flux is coming down, the EMF is picking up. Ready what Faraday says? Clear? Let's see our next orientation. Our next orientation will be typically the same orientation as we were in the first one. Do you agree or not? But there is a change now. The orientation will be on this side because it is rotating. Look. Yes or no? It is rotating. So now, if you see the E at a time t, it will be E naught sine 180 degree, which is again equal to 0. Which is again equal to 0. And flux will be now pointing on which side? Flux is pointing on this side. But flux will be maximum. Just that flux is pointing on the opposite side. Clear? Okay. The next is again the same copy of this, but there will be a small change. It will actually go in this direction. It will go in this direction. Instead of here, area vector will go that side. So now my E at time t will be given by E naught sine 270, 90, 180, 270. So this will be negative E naught. Sine 270 is negative. Sine 270 is how much? Negative 1. So look at the, if you see the sine values, let me write the sine values in yellow. If you see the sine value, sine 0, 0, sine 90, is equal to 1, sine 180 0, sine 270 negative 1. This is the mathematical proof that your EMF is changing direction. E0, E max positive, E0, now you are getting a E0 negative max. Arjun, is it clear or not? You are getting a E0 negative max. So we should have one more diagram also. So can I rub this portion? I'll just rub this portion and let's bring one more diagram. And our next diagram will be exactly this 360 and 360. This is the last one, bacha, right? The only change I will put here is that this fellow theta is now equal to 360 degree, which is same as sine 360 will also give me a 0. So your E becomes 0. So let's write sine 360. Arey yaar. So we write sine 360 is equal to 0. If you want this thing in radians, then I can write here we have 0 rad. Here it is theta is equal to pi by 2. Yes, theta is equal to pi. Theta is equal to how much? 3 pi by 2. Very good. So this is 0, pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, where theta is equal to 2 pi. Clear? Acha. Now understand. Wait. The whole thing is this coil is rotating with an angular velocity which is constant. Now use your common sense and tell me. Angular velocity is how much, beta? Constant. And this to this is one cycle. Do you agree? The orientation was this and you came back as this. The period has been repeated. Let this time be a capital time t. Then each of these intervals happened at what? Exact equal intervals, because the rotation was constant. So if this was, let's say here, if this is t is equal to 0. This is half t. This is 1/4 t. This is half t. This is 3t by 2. And this is 4t by 2, which is equal to, or else if you take it as, say, let's t is equal to 0, 1/4, half, 3/4, and this is t. 3 by 4th, yeah, sorry. This will be 3 by 4th. My mistake, beta. This will be 3 by 4th. 3 by 4t and t. Clear? What is t? T in our periodic language, what we'll say? T is the time period. T is what? T is the time period. So let's say this is the time scale. This is the time scale. We are measuring the time scale out here. Hold on. We are measuring the time scale. And on this side, obviously, we will be measuring our signal strength. So this is the EMF scale. Okay? And how is your time scale divided? Your time scale, we will make it absolutely equal. So there is a 1/4, 1/4, 1/4, and 1/4. Children, what is the nature of the function? The nature of the function is a trigonometric function which is sinusoidal. And what is the maximum value of sine? 1. The maximum value of sine is 1. But every time you are becoming 1, you have a coefficient E0 also with you. So the maximum value you are picking up is E0. Sine omega t is 1, but you have a coefficient E0, right? Say E0 is donkey, so the maximum value is donkey. So let me put two more parallel lines here. Let this be E0. Similarly, you will have a negative E naught also out here. Yes or no? Right? Enjoy this. And your function is what? Sine function. So your sine function will go in what manner? It will, let me draw the function with the blue curve. Yeah. So we will pick a maximum value here and again become 0. And again we will pick a maximum value here and become 0. This is the sine curve which we are going. And our curve is given by E at a time t is given by E naught sine omega t, which we'll be using in our next class. So what is this value? This value is, why do I write epsilon here every time? Okay, this is E naught sine omega t. That means this is E naught and this value is negative E naught. Now wait, come back to vibrations chapter. This is to and fro movement. The maximum displacement from the central position is always called the amplitude. So what is your amplitude? Your amplitude is E naught. E naught is my amplitude. So the current that is coming in our house, then you should say, sir, sometimes we should not get a shock at all. Correct. Correct. But this is happening. So it's like this. Say suppose I slap on someone's cheek like this. There's a frequency. Every time it comes here, move your face, but increase the frequency. Do you feel any moment that you are not getting a slap? You're getting a slap every time. There is no moment that you'll physically feel that the voltage has come to 0, but the voltage is coming to 0. The bulb cannot recognize it, but the oscilloscope will recognize it. And when we design, see, when we design in electricals, you have these things, right? Where you can have on mobiles, say suppose you have a scroller bar with which if you increase it, the intensity of the fan increases or light increases. That programming in computer we do for 0 crossover points. These points are called 0 crossovers. At this moment, the microcontroller has to sync. Then only if you increase, it will increase like this. So much of engineering is put into that. Happens, sometimes when you have when you're having computer integration to electricals, these are there. I mean, is there on my channel also videos where suppose this fan can only have speeds in steppers, but suppose there is a moment now when 1 is very slow for me and 2 is very fast for me. I want more precise control. How will you do? You have to now bring a microcontroller, and at that time you can control it by 2 ways, either through a glider or you can give a command like, I'll not use the word because otherwise that will become sensitive. Hey G, set the speed to 44%. So it will exactly rotate at 44%. 46%, that is called fine control. That controls happen over here. Did you understand this basic? This was what was explained in your NCERT diagram, which is this particular diagram, the same thing. So now you'll understand this. Look, the A vector is here. So 0. After this, T by 2, T by 4. This is the funda. So next chapter, when you are going, you will go with, you will say that the EMF at any time t is given by E naught sine omega t. Sine omega t. And you have just learned from your previous chapter that, not from previous chapter, from from inductance, that E is also given as L minus L di by minus L di by dt. So if the current is with cos, the voltage will be with sine. And there you will learn voltage leads or lags current. So if somebody says, see, a current is also an equation of this. So you will get current equation in next chapter like this. I equal to I naught cos omega t. At that time, the voltage will be given by V naught sine omega t. This is which is coming for you in the next chapter, where we will be start learning alternating currents. Is this clear? That's all. So और कुछ समझाने का नहीं है. This much was the only thing. Get doing numericals based on these things. See, end of the day, in this chapter, what all did you study? You studied Lenz's law. you studied what you call Faraday's law, right? You also saw Faraday's law as E equal to minus d phi by dt. Then you saw Lenz's law why the minus comes. Then we also studied about mutual inductance. M12 is equal to M21 equal to M. And otherwise inductance is L. Current net flux divided by your inductance. Inductance tells you how much is the net flux build up with respect to per unit current. And from there we came to that definition that EMF is always minus M di by dt or minus L. These things will come in next chapter. So EMF is a function of magnetic flux, and then EMF can also be said as inductance into derivative of current is equal to minus L di by dt. That will come up in our next chapter. Is this clear? They might ask you questions here like why when the flux is maximum, why is the EMF minimum? EMF has nothing to do with flux. EMF has to do with rate of change of flux, and Faraday's law says that the EMF is negative rate of change of flux. That means if the flux decays, your salary is linked to negative production rate. Don't work in the factory. Your salary will increase. Negative production rate. This fellow last month produced 200 footwears. This month he has produced 400 footwear. Should I increase his salary? No, because his salary is linked to negative production. Sir, this year I have done only 100 footwears. Very good. Give him a promotion. Negative. So whenever the flux is coming down, you see every time flux comes down, the EMF builds up. And whenever the flux builds up, the EMF comes down. Clear hua? That's all. Start doing your practicals, your problems, so that